We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard. Because that goal will serve to organize and measure the best of our energies and skills. Because that challenge is one that we're willing to accept, one we are unwilling to postpone.
Four, three, two, one. Ignition.
Procedure 11.100, Section 3 on LZ-1 BNet.
Zero and liftoff, the final liftoff of Atlantis on the shoulders of the space shuttle. America will continue the dream.
Ferguson rotating the nose gear down to the deck.
Lock the doors. Copy.
"38 miles above ground, the space shuttle had exploded.
4%. Challenger, go and throttle up. Roger, go and throttle up.
The shuttle mission will launch. My God.
1 minute 15.
There's been an explosion.
Velocity 2,900 feet per second, altitude 9 nautical miles, downrange distance 9, 8, 7, 6, 5, 4. We've gone for main engine start. We have.
To go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
and gentlemen, welcome back to another live stream on the Beren Society of Young Astronomers Facebook page. I am your commander, Jessica Scollen, president of the BSYA, and I'm here to welcome you all as we talk about the history of modern astronomy. But more on that later. First, what are we exactly? We are the official astronomy club of San Beda University, Manila, in the pursuit of promoting the sciences to all audiences, as we dream to one day we may reach for the stars. Our club moderator is Sir June Cahigal, and without him, all of this would not have been possible. Tonight's stream, we'll be talking about the history of modern astronomy, which dates back over hundreds of years, from the likes of Aristotle, Tycho Brahe, Isaac Newton, Galileo Galilei, and many more. Our talk will be focusing more on their contributions to modern day science. So if you like what you see and you want to see more, show your support by liking our Facebook page at the Beren Society of Young Astronomers. And while you're at it, follow us on Twitter at BSYA_Manila. At BSYA_Manila. That is capital B, capital S, capital Y, capital A, underscore, and capital M, Manila. For more updates, interactive discussions, Q&A submissions, geeky news, and many more. So please follow us at BSYA_Manila. And without further ado, may I introduce our speaker, Sir June Cahigal, a Star Trek lover, our Earth Sci and Bio teacher, and of course, our club moderator. So without further delays, you may sit back, relax, take some notes, and enjoy the rest of the stream.
Hello, greetings. This is Professor June Cahigal, and welcome to part 2 of the origin of modern astronomy. Now, if you will recall, in part 1, we were able to trace the beginnings of modern astronomy from the prehistoric times up to the time of Johannes Kepler, wherein he developed the laws of planetary motion. Now, for this episode, we will zoom in on the contributions of Galileo Galilei, Isaac Newton, and Edmund Halley. Alright? Okay, so let's start now with Galileo Galilei. Now, Galileo invented the modern view of science, a transition from a faith-based science to an observation-based science. So basically what he did is he invented the scientific method. Okay, so from faith-based to an observation-based science. So he came up with the scientific method of solving problems. Okay, and also Galileo greatly improved on the newly invented telescope technology. But again, if you will recall, the telescope was invented not by Galileo, but a Dutch lens maker by the name of Hans Lippershey. Okay, it was Hans Lippershey who came up with the first telescope. Okay? Alright. So that's the portrait of Galileo Galilei. And let us now zoom in on his personal life. Okay, the life of Galileo Galilei. Now, Galileo was born in Pisa, Tuscany on February 15, 1564. And during his middle teens, Galileo attended the monastery school at Vallombrosa near Florence, Italy, and then in 1581 matriculated at the University of Pisa, where he was to study medicine. Okay? Now, however, he became enamored, or he fell in love with mathematics and decided to make the mathematical subjects and philosophy his profession against the protest of his father. So, yung tatay niya, siguro gusto niyang mag-aral si Galileo ng medicine. Okay? But Galileo fell in love with mathematics and philosophy. So Galileo decided to make the mathematical subjects and philosophy his profession. Kahit ayaw ng mga magulang niya, especially his father. Now, in 1585, Galileo left the university without having obtained a degree. Now, quite unusual. And for several years, he gave private lessons in the mathematical subjects in Florence and Siena. Now, this is quite unusual. We know Galileo to be a genius and one of the respected scientists of his time, but he left the university without having obtained a degree. Okay? And naging private tutor na lang siya in the mathematical subjects. Alright. Then Galileo demonstrated by dropping bodies of different weights from the top of the famous Leaning Tower of Pisa that the speed of fall of a heavy object is not proportional to its weight, as Aristotle had claimed. Alright, so I want you now to take a look at this illustration of the Leaning Tower of Pisa. Alright, now during the time of Aristotle, they believed that if you drop from a certain height two objects of different masses or different weights, so one is heavier as compared to the other object, then the heavier object would hit the ground first as compared to the lighter, less massive object. Now, Galileo changed all that, okay, by demonstrating that by dropping two objects of different masses, of different weights from a certain height, then these two objects would hit the ground at the same time. All right? So that's really revolutionary. The idea of two objects of different masses when dropped from a certain height would hit the ground at the same time. Okay? And actually this experiment was conducted on the lunar surface. Okay? The moon has no atmosphere, so the two objects would not encounter any air resistance. So the astronaut dropped a hammer and a feather, then both objects hit the lunar surface at the same time. Okay? Fascinating, isn't it? But again, this demonstration at the Leaning Tower of Pisa, we really don't know kung talagang dun nga siya sa Leaning Tower of Pisa. This was only documented by the biographer of Galileo. But we really cannot confirm kung talaga nga siyang nag-demonstrate doon sa Leaning Tower of Pisa. Okay? So that led to the development of the law of freely falling bodies by Galileo. Alright? So fascinating, isn't it? Alright. Okay. Now Galileo did not marry, but he did have an arrangement with a Venetian woman, okay, named Marina Gamba, who bore him 2 daughters and a son. Okay, so may mga anak din pala si Galileo. Okay, 2 babae at 1 son. And in the spring of 1609, he heard that in the Netherlands, an instrument had been invented that showed distant things as though they were nearby. So, ito na yung invention ng telescope ni Hans Lippershey. Okay, then by trial and error, he quickly figured out the secret of that invention and made his own. So, nung nalaman niya yung invention ni Hans Lippershey, yun, pinag-aralan niya. So, he quickly figured out how the telescope worked and he made one for himself. Okay, so this was the telescope that Galileo had assembled. This telescope is called a refracting telescope. A refracting telescope uses lenses to produce a magnified image of the distant object. And Galileo sold some of his telescopes to the military. Okay? Kasi ang military, malaking pakinabang itong telescope na ito. They can easily spot enemy ships or pirates. Kaya ang tawag dito noon ay spyglass. Okay? So, binenta niya yung telescope niya sa military. But when Galileo started pointing his telescope towards the night sky, yan, nagbago ang lahat. Okay? It was a revolution kasi marami siyang na-discover when he pointed that telescope towards the night sky. And he made public telescope viewings. Okay, in Italy yan. So, pinagyabang niya yung kanyang telescope at yung kanyang mga na-discover dun sa telescope na yan. Okay? Alright, so that led to the birth of modern astronomy, the use of the telescope for observing the night sky. Okay, so he developed his own telescope and made the following discoveries. Alright, now Galileo discovered the 4 largest satellites or moons that orbit Jupiter. Now, we know that Jupiter is orbited by 64 plus moons. But Galileo discovered the 4 largest moons or satellites of Jupiter. Okay. Then Galileo also concluded using his telescope that planets are circular disks and not just points of light. Okay? Galileo also pointed his telescope towards the moon, and he saw the moon's surface with craters, with mountains. So according to Galileo, the moon's surface is not smooth. Kasi noon, akala nila ang buwan parang crystal ball na smooth. But when Galileo pointed his telescope towards the moon, Galileo saw craters, Galileo saw mountains. So, hindi pala smooth ang moon. Okay? Then, Galileo also pointed his telescope towards the sun. And he discovered sunspots or dark regions on the sun's surface. Kaya lang nasira yung mata ni Galileo. Kasi walang filter yung telescope niya. And Galileo also pointed his telescope towards Venus. And he observed that Venus exhibited phases much like the moon. Yung nagbabago yung shape, yung may crescent Venus, may quarter Venus, much like the moon. Alright? So those are some of the significant discoveries made by Galileo using that telescope. So Galileo again was able to observe the 4 moons of Jupiter, the 4 largest moons of Jupiter. So we know them now as the 4 Galilean moons. Okay, so this is what he saw through his telescope. Yan. So yung red dot, that's Jupiter. Then itong mga 4 smaller dot, those are the 4 largest moons of Jupiter or the Galilean moons. So we know them as Ganymede, Callisto, Io, and Europa. Okay? So those are the 4 largest moons of Jupiter. Okay, Galileo also observed the rings of Saturn. Okay, ito yung nakita niya, parang parang rabbit's ears. Hindi nga lang niya ma-confirm kung talagang rings yan or what, but that's what he saw. Okay, so Galileo was the first to observe the rings of Saturn. Okay, fascinating, isn't it? Alright, Galileo also pointed his telescope towards the moon. Okay? And that's what he saw. He saw craters, he saw valleys, and mountains, much like the Earth. Okay? And he also pointed his telescope towards the sun. And he observed sunspots or dark regions on the sun's surface. Okay? So, kaya lang 'di ba nasira yung mata niya kasi walang filter yung telescope niya. Okay? So, he was the first to observe sunspots, proving that the sun is not perfect kasi may mga dark regions. All right? So, that's his actual drawing of the sun with sunspots. Okay, fascinating, 'di ba? All right, and he pointed also his telescope towards Venus. And according to Galileo, Venus exhibited phases much like that of the moon. So merong crescent Venus, may quarter Venus, may gibbous Venus, much like that of the moon. And this was the turning point of Galileo's discoveries. So by observing that Venus exhibited phases, this would only prove one thing, that Venus revolves around the sun. Okay? So that means that the sun is at the center of the universe and not the earth. Okay? This would contradict the Ptolemaic model of the universe. And this will support the Copernican model. Diba? If you will recall, Nicholas Copernicus had proposed that the sun is at the center of the universe. Yung kanyang Copernican model. Now, when Galileo observed Venus, and Venus exhibited phases much like the moon, ito na yung ebidensya na hinahanap, that Venus revolves around the sun. Alright, so let's take a look at this animated illustration. So as you could see here, that from our perspective here on Earth, Venus exhibits phases much like that of the moon. So we can observe Venus having a crescent shape, then quarter Venus, gibbous Venus, and full Venus, much like that of the moon. Now, this means only one thing for Galileo, that by observing Venus changing shape from time to time, it means only that Venus revolves around the sun and not Venus revolving around the earth. So this observation of Venus supported the Copernican model of the universe. Okay? Amazing, isn't it? So this observation of Venus was the turning point in support of the Copernican model. Ito na po yung ebidensya na hinahanap ni Copernicus, ni Tycho Brahe, ni Johannes Kepler. Okay, that Venus changing shape from time to time, and that means only that Venus revolves around the sun and not Venus revolving around the earth. Okay? Alright, so Galileo's increasingly overt Copernicanism began to cause him trouble. Ayan, kasi 'di ba sinusuportahan ng karamihan yung geocentric model ni Ptolemy. All right? Several clergymen in Florence lodged complaints against Galileo in Rome. And Galileo went to Rome to defend the Copernican cause and his good name. Now, Galileo made demonstrations of his telescope to the clergymen. All right? But unfortunately, Galileo failed to convince them. So parang ayaw maniwala ng mga clergymen, yung mga taga-simbahan, kay Galileo, kahit nakitang-kita na nila sa sarili nilang mga mata that Venus follows or exhibits phases or the four moons of Jupiter, parang hindi sila konbinsido dun sa mga discoveries ni Galileo and in support to the Copernican model of the solar system, of the universe. And eventually, the Inquisition filed a case against Galileo. Dinimanda si Galileo by the Inquisition. The Inquisition is like a special court of the church, all right, during that time. So a case was brought against him by the Inquisition. So ano yung kaso? Okay, he was pronounced to be vehemently suspect of heresy, yung manloloko, yung manlilinlang. And eventually he was condemned to life imprisonment. He was found guilty and he was condemned to life imprisonment. Dapat nga kamatayan yan eh, because the punishment for heresy was death. Kaya lang because he was old and weak, his sentence was reduced to life imprisonment. And ang masakit pa niyan, he was made to abjure formally. Abjure meaning to recant or to renounce his belief of the Copernican model. Yun yung masakit. So sinabi ni Galileo in public na tama si Ptolemy, that Ptolemy was correct and the earth is at the center of the universe. So mali daw si Copernicus. The earth is at the center of the universe and not the sun. Kahit na tama yun, kahit kitang-kita na ni Galileo, wala. He was forced to recant or to renounce his belief of the Copernican model. Okay? Kawawa naman si Galileo. Okay? Ang hagan lang niya ay ang katotohanan. Kaya lang he was made to abjure his beliefs. By then, Galileo had become blind and he spent his time working with a young student. Meron siyang apprentice by the name of Vincenzo Viviani. Ito rin yung kanyang biographer, who was with him when he died, when Galileo died on January 8 of 1642. Okay? So, kawawa si Galileo. He was accused of heresy and he was found guilty of heresy and he was punished to life imprisonment. Okay? So, yun yung kapalaran ni Galileo. Okay? And he was forced to abjure or to renounce his beliefs na tama si Ptolemy at mali si Copernicus. In spite of the fact that Galileo had accumulated enough evidence using his telescopic observations to support the Copernican model of the universe. Okay, so that was the life of Galileo Galilei. Alright, so at this point, let us now study the contributions of Sir Isaac Newton to modern astronomy. So here is a portrait of Sir Isaac Newton, and let us now dig deeper into his personal life. Now, Isaac Newton was born in England on Christmas Day. December 25, 1642. And Newton was the only son of a prosperous local farmer, also named Isaac. So pareho sila ng pangalan ng tatay niya, who died 3 months before he was born. So hindi na niya nakita yung tatay niya, namatay kasi kaagad 3 months before Newton was born. Newton was born a premature baby that's tiny and weak. So they never expected Newton to survive, but miraculously Newton did survive. Okay? And when Newton was 3 years old, his mother Hannah Iskopf Newton remarried a well-to-do minister by the name of Barnabas Smith and went to live with him, leaving young Newton with his maternal grandmother. So, lumaki si Newton sa lola niya. Then, at age 12, Newton was reunited with his mother after her second husband died. She brought along with her 3 small children from her second marriage. So, may mga kapatid siya from the second marriage of his mother. All right. The experience left an indelible imprint on Newton, later manifesting itself as an acute sense of insecurity. He anxiously obsessed over his published work, defending its merits with irrational behavior. So, because of his not so good experiences during his childhood or formative years, medyo nagkaroon siya ng sense of insecurity si Newton. So, medyo naka-apekto po yan sa kanyang personality. Okay? So, naging obsessed si Newton sa kanyang trabaho. Okay? And medyo yung behavior niya medyo irrational, medyo maiinitin ng ulo, madaling magalit. So, ganyan si Newton when he was young because of his experiences, the not so good experiences when he was in his formative years. Alright, so what about his education? Now, Newton was enrolled at the King's School in Grantham. So that's a town in Lincolnshire where he lodged with a local apothecary and was introduced to the fascinating world of chemistry. So when he was introduced to chemistry, naging mahilig po siya sa alchemy. So I'm sure you're familiar with alchemy. So mixing different metals to form gold. Okay, so medyo naging obsessed dyan si Newton sa alchemy because he was introduced to this fascinating world of chemistry. Then his mother pulled him out of school at age 12. Her plan was to make him a farmer and have him tend the farm. So gusto ng nanay niya magbungkal ng lupa, tulungan siya dun sa kanilang farm. Now Newton failed miserably as he found farming monotonous. So ayaw ni Newton yung pagfa-farm, ayaw niya nan. So parang naging boring para sa kanya. Newton was soon sent back to King's School to finish his basic education. Now that was really interesting about Isaac Newton. So when he enrolled in King's School, he was introduced to chemistry and he was obsessed with it. And he was engaged in alchemy eventually. Then yung nanay niya, pinull out siya dyan sa school na yan at age 12. Her plan was to make Newton a farmer. Okay, but Newton finds farming monotonous or boring. So, walang nagawa yung nanay. So Newton was soon sent back to King's School again to finish his basic education. Okay? So yun talagang gusto ni Newton, gusto niya mag-aral. Okay. So at this point, let us now go into the details of some of the significant discoveries of Sir Isaac Newton. Alright, so Newton made discoveries in optics, motion, and mathematics. Newton theorized that white light was a composite of all colors of the spectrum, and that light was composed of particles. So I'm sure you know the story of that. Newton allowed white light to pass through a prism or a triangular piece of glass. Okay, and he noticed that as white light passes through the prism, it's separated into different colors. Okay, and Newton was also responsible for the corpuscular theory of the nature of light. According to the theory, light was composed of particles. Okay, that's according to Newton. And his momentous book on physics, entitled Principia, contains information on nearly all of the essential concepts of physics except energy, ultimately helping him to explain the laws of motion and the theory of gravity. All right? Okay, so here is an illustration of Newton allowing white light to pass through a triangular piece of glass or prism. Okay, and the white light was separated into different colors. Okay, and Newton also was responsible for the so-called corpuscular theory that light was composed of particles. Okay, so that's fascinating, isn't it? Okay, all right, so light, according to Newton, is composed of particles. All right, so this was his book called Principia. Principia contained most of his significant discoveries, like those in optics, mechanics, okay, motion, and gravitation. Okay, and speaking of gravitation or gravity, there was this legend about the falling apple. Okay, and this was the inspiration for Newton to come up with his laws of gravitation. Kaya lang there was no evidence to prove that nangyari nga ito, yung nahulugan siya po ng mansanas, and that led him to come up with the concept that objects must fall down. Okay? So, hindi natin alam. Pero he got probably an inspiration. Nakikita niya na nahuhulog yung apple. Pero hindi naman po siya natamaan ng apple sa ulo. Alright? Okay, so that's the apple myth. Kaya lang naging famous na po ito. That's why we have Newton's apple. Alright. So, the laws developed by Newton, the laws of gravitation, particularly helped explain not only the elliptical planetary orbits of Johannes Kepler, but nearly every other motion in the universe. Okay, how the planets are kept in orbit by the pull of the sun's gravity, how the moon revolves around the earth, and the moons of Jupiter revolve around it, and how comets revolve in elliptical orbits around the sun. Remember, Johannes Kepler developed the laws of planetary motion. So Kepler was able to describe in detail the motions of the planets, but he cannot explain the reason for their behavior. And Newton provided that explanation through his laws of gravitation. Amazing, isn't it? Okay, so the law of gravitation explained the behavior of the planets as proposed by Johannes Kepler. Okay, Kepler was able to describe in detail the motions of the planets through his laws of planetary motion. Now, the law of gravitation by Isaac Newton provided the explanation of the behavior of the planets. Okay? All right. Now, aside from the law of gravitation, Newton also came up with the laws of motion. And I'm sure you're familiar with the 3 laws of motion of Isaac Newton. Okay, the first law is the law of inertia. Though inertia was already conceptualized by Galileo Galilei. Okay, so according to the first law, a body at rest or in uniform motion will remain so unless acted upon by an unbalanced force. So meaning an object will keep on doing what it is doing. So if the object is at rest, it will remain at rest. If the object is in motion, it will remain in motion. So an object keeps on doing what it is doing. Alright, so second law of motion is the law of acceleration. And according to this, the change in motion or acceleration is proportional to the unbalanced force. Hence, we have the formula F equals m times A. So if you apply more force, then the object will accelerate. Okay? Alright, and the third law is the law of action-reaction. So for every action, there is an equal and opposite reaction. Okay, and did you know that Isaac Newton was also an inventor? Yes, Newton was an inventor. And one of the significant inventions of Sir Isaac Newton was the reflecting telescope. Okay, here is a replica of the reflecting telescope made by Isaac Newton. A reflecting telescope uses mirrors instead of lenses to produce a magnified image of the distant object. Remember, Galileo came up with his own refracting telescope based on the design by Hans Lippershey. Now, the telescope made by Galileo uses lenses to produce a magnified image of the distant object. But they realized that lenses produces chromatic aberration or color fringes. But this reflecting telescope eliminates those color fringes. Okay, this reflecting telescope uses mirrors instead of lenses. And the biggest telescopes in the world are reflectors, thanks to Sir Isaac Newton. Now, the telescope had revolutionized the way we observe the night sky. Galileo came up with his telescope based from the design made by Hans Lippershey that uses lenses to produce a magnified image of the distant object. And Isaac Newton came up with his own unique design of the telescope by using mirrors instead of lenses to collect light and to produce a magnified image of the distant object. So really, the telescope age has come. Alright, so the telescope really had revolutionized the way we observe the night sky. Okay, so this is my telescope. So I call this telescope the Hulk. Kasi malaki po yung objective lens. The objective lens has a diameter of about 120 millimeters. And I really love this telescope. So kahit mahirap yung buhatin and mahirap po yan i-transport, Really, I love that telescope, which I named as the Hulk. And the Beden Society of Young Astronomers conducts public telescope viewings at malls, parks, and even in schools. So these are just some pictures taken when we conducted a public telescope viewing at San Beda College, Alabang. Okay, so these are just some of the students from San Beda College, Alabang, when we conducted a stargazing activity. Okay, and this is a picture taken when we conducted a public telescope viewing at Carmona, Cavite. So in a certain school in Carmona, Cavite, we conducted a public telescope viewing. So that's what PSYA does. Aside from conducting lectures, we also conduct free public telescope viewings. Okay? Alright, so here is my telescope, my Meade 90mm refracting telescope. And the largest telescope in the world is this telescope at Yerkes Observatory. This is the so-called Yerkes refracting telescope. The Yerkes refracting telescope has an objective lens with a diameter of 40 inches. My gosh, 40 inches. Ang laki po niyan. Okay? So this Yerkes telescope really is the largest refracting telescope in the world. Okay? Ayan, makikita niyo itong tao na ito compared to the size of the telescope. Alright? Okay. Now, the refracting telescope suffers from a defect. Okay? So, the refracting telescope suffers from what we call chromatic aberration. Or in other words, that the lenses of the refracting telescope produces color patterns or color fringes. Parang prism po. So, the lenses produces red, yellow, and blue color fringes around the image. But modern telescopes now has correcting lenses that minimizes chromatic aberration. Alright? Okay. So, the lenses produces these color fringes. So, may blue, may green, may red dun sa image. So, something like this. Okay? And this is not good in observing, let's say, the moon or the star or planets because it may affect the quality of the image. So, hindi maganda po yung chromatic aberration because that's one of the qualities of the lenses. Kasi ang lens parang prism po yan that breaks down light into colors. So, this refracting telescope suffers from chromatic aberration. Okay, so that's chromatic aberration. So here is another picture of a group of stars taken using the refracting telescope. And you can see some of the color fringes surrounding the images of those stars. And these color fringes may affect the quality of the image produced by the refracting telescope. Now, Isaac Newton came up with a unique design. Now, instead of using lenses that produces this so-called prism effect, Isaac Newton made use of mirrors to focus light and to produce the magnified image of the distant object. So, Isaac Newton came up with a new type of telescope called the reflecting telescope. A reflecting telescope uses a concave mirror to focus the light and produces that magnified image of the distant object. And most large telescopes today are reflectors. A reflecting telescope does not suffer from chromatic aberration. So you have sharper images if you're using a reflecting telescope. Okay, so here is the basic design of a reflecting telescope designed by Isaac Newton. This is called the Newtonian reflecting telescope. So light enters the body tube of the telescope and it bounces off a primary concave mirror. Then the primary mirror reflects the light onto a secondary flat mirror, and then the image is reflected onto an eyepiece. Okay? So this design was made by Isaac Newton himself. So this is known as the Newtonian reflecting telescope. Amazing, isn't it? And most amateur astronomers uses the reflecting telescope. This is the workhorse of amateur astronomy, the Newtonian reflecting telescope. And this was my first Newtonian reflecting telescope. And I named this Mizar 1. Okay, ito po yung kauna-unahan kong reflecting telescope. I saw this at a Japan surplus shop at nakatambak lang po doon. Ang dumi-dumi. And hindi alam po ng may-ari kung ano yan, kung paano gamitin. So, binenta po sa akin for only, would you believe, 2,000 pesos. Pero pag brand new yan po, mahal po yan. But the owner of the Japan surplus shop sold that telescope to me for only 2,000 pesos. Grabe. So what I did, I cleaned the mirrors, I aligned the mirrors, I painted the body tube, and voila! That's Mizar 1. Okay, at yun ang ginagamit ko po in our free public telescope viewings. Maganda po yung quality ng telescope na to nung naayos ko. That's Mizar 1. Okay? Hindi ko po kayang bumili ng brand new kasi medyo may mga kamahalan po yung mga branded and brand new telescope. But that didn't stop me because ito, marami namang second hand na telescopes dyan. Okay? And kahit mo naman walang telescope, it will not hinder you from loving astronomy. Just look up at the night sky at mai-inlove na kayo sa astronomy, sa kalawakan, even without the telescope. Okay, so that's the reflecting telescope. Ito naman din, ginagamit ko din ito in our free public telescope viewings. Okay, I named this telescope YT. Yan, YT. Pero hindi po sa akin yan. This telescope is owned by Gary Andreasen from the Manila Street Astronomers. Okay, malakas din pong telescope na ito. This is YT, a Newtonian reflecting telescope. Okay, and these are just some of the students from San Beda College, Alabang. Okay, so that's the reflecting telescope made by Isaac Newton. All right, and this is the largest reflecting telescope in the world. Okay, the Gran Telescopio Canarias in Spain. Okay, so ito po yung pinakamalaking telescope, reflecting telescope sa buong mundo. So you can see the primary mirror. Okay, ang laki po ng primary mirror na yan. Alright, and this is the Keck telescope. Malaki din po to sa Hawaii. Okay, the so-called Keck telescope. Okay. Ayan, so that's the Keck Observatory in Hawaii. And this is the Hale telescope at Mount Palomar in California in the United States. Okay, so that's the Hale reflecting telescope. Most large telescopes are reflecting telescopes. Okay, so that's the Hale telescope. The Hale telescope is so big that the astronomer is actually seated inside the telescope tube itself. Fascinating, isn't it? Okay, so that's the reflecting telescope. Most large modern telescopes nowadays, even the Hubble Space Telescope, are reflecting telescopes. Okay, so let's continue now with the contributions of Edmund Halley and Isaac Newton to modern astronomy. Now, Newton and Edmund Halley were really good friends. Magkaibigan tong dalawa. And Edmund Halley aided in observationally proving Isaac Newton's laws of motion. And you would be surprised that Edmund Halley also was responsible for funding the printing and the publication of Newton's influential book entitled Principia. Okay? So kung hindi dahil kay Edmund Halley, hindi masusulat, hindi mapapublish ni Newton yung Principia na yan. So that book, Principia, contained Newton's works on gravitation, motion, kinematics, optics. See? So without Halley, there won't be Principia. Alright? So that's Edmund Halley. Edmund Halley helped Newton in the publication of that book, Principia. And from his September 1682 observations, Edmund Halley used the laws of motion of Isaac Newton to compute the periodicity of that comet, which was named after him, yung Halley's comet na yan, upon its predicted return in 1758, which he did not live to see. So really, Halley and Newton were really good friends. They share information about their works. Okay? So yan yung dalawang yan. Magkaibigan yan. Okay, Halley and Newton. And again, without Edmund Halley's intervention, Newton would not be able to publish his influential book called Principia. So Edmund Halley basically funded the printing and the publication of Newton's Principia. Yan, yung nagawa po ng pagkakaibigan ng dalawang yan. Alright? So with Halley's financial support, Newton was able to write and publish that book called Principia. That book revolutionized science. Okay, in physics, optics, mathematics. Okay, that book really had changed the world. Now, you might have the impression that the only contribution made by Edmund Halley was predicting the coming of that comet, which was named after him. Now, Edmund Halley made several achievements in science. So let us now enumerate some of the achievements made by Edmund Halley. Okay? Now, Edmund Halley mapped the stars of the southern hemisphere. He was responsible for mapping the stars of the southern skies. And that was quite an achievement during his time. Edmund Halley also was responsible for mapping the Earth's magnetic field. Fascinating, isn't it? And did you know that Edmund Halley was also an inventor? Edmund Halley invented the diving bell. The diving bell allowed workers to stay underwater for several hours. So parang ano ito, parang underwater habitat so that the workers can do their thing underwater, like fixing bridges, yung mga foundations ng bridges. So that's a diving bell, and that was invented by Edmund Halley. Okay? Plus the fact that Edmund Halley applied Newton's mathematical laws to predict comets. Yung pagbalik po ng comet, like the comet that was named after him. He was able to predict the return of that comet, which was named after him, yung Halley's Comet, in 1758. Okay, So I guess that's it for the origins of modern astronomy. So we would like to thank everybody, those who have watched and shared this live stream event. So I'm sure you have learned a lot about this topic on the history of astronomy. This is for all the students out there, especially those who are taking earth science. Okay, the Vedan Society of Young Astronomers, we aim to help students with their education. So I hope that you have learned a lot about this topic on the origins of modern astronomy. Please like and share this live stream, and please like and share our Facebook page, the Vedan Society of Young Astronomers. So we will now proceed to the live open forum.
We choose to go to the moon in this decade and do the other thing, not because they are easy, but because they are hard. Because that goal will serve to organize and measure the best of our energies and skills. Because that challenge is one that we're willing to accept, one we are unwilling to postpone.